Fishermen are leaving the dock under clear skies, then coming back empty, confused, and uneasy. Sonar goes quiet. Familiar grounds stop producing. Entire zones close without storms, spills, or warnings. Official records say one thing. Logbooks say another. Oxygen vanishes. Water turns toxic. Fish disappear without floating to the surface. And no single agency admits it's all connected. What's really happening beneath the water? And why is it accelerating when familiar waters began to fail? In late July and early August 2024, captains out of Venice, Louisiana, and Port Fourchon described a familiar pattern that still made them adjust their days. When the Gulf of Mexico's low oxygen zone expands, shrimp and finfish do not spread evenly across the bottom. They compress into edges and pockets. Trawls come up with mixed sizes in odd ratios. Some crews mark the same coordinates repeatedly because the workable water narrows without looking different from the surface. On the 1st of August 2024, NOAA-supported scientists reported the measured hypoxic area at about 6,705 square miles, larger than the early season forecast and within the long record that has been tracked for decades. The effect is not a single event that makes the news, and the language used on the dock stays plain. A deckhand might say the water doesn't hold the way it should. A captain might say the sounder looks clean until it does not. These are not descriptions of a new phenomenon. They are working notes, exchanged at ice houses, fuel docks, and in short radio calls when boats cross paths at dawn. NOAA's release described hypoxia as bottom water with very low oxygen that can make habitat unavailable to fish and bottom-dwelling species. That framing matches what crews already know from experience. The catch can shift without a storm, without a visible slick, and without an obvious line on the horizon. Further north, on the Chesapeake Bay, the reported anomalies often arrive as arguments about absence rather than sightings. In the winter of 2023 into early 2024, commercial and recreational fishers in Virginia and Maryland talked about menhaden in the way they have for generations, as bait, as forage, as a sign that other fish will follow. The dispute, as described in reporting from February 2024, was not centered on a single die-off. It was about whether the population is slipping, how it is being measured, and whether the remaining large industrial fleet is taking too much from the same places too often. Residents and fishermen described localized changes in where fish were seen and what predators were doing around them, while the company involved contested the broader claim of decline. On some mornings in spring, the surface can look normal, while the water column behaves differently than expected. Fish can stack deeper or avoid a band of water that does not show on the eye. Anglers describe days when stripers and bluefish should be there, but are not, then reappear miles away along a subtle boundary. The observations are not proof of a single cause, and most working crews do not speak in causes anyway. They speak in patterns that change their fuel burn and the time they spend searching. What makes these reports feel like anomalies to the people living them is the frequency of days that do not match the old calendar. On inland waters, the anomalies can be more direct because they carry a smell and a color that is hard to ignore. Lake Erie, which supports charter fishing and coastal bait businesses from Toledo to Sandusky and eastward, has long dealt with harmful algal blooms. The detail that changes year to year is not the existence of bloom risk, but its timing, thickness, and where it pushes people off the water. On the 28th of June 2024, NOAA's National Center for Coastal Ocean Science issued a seasonal forecast that projected a moderate bloom severity. Similar to the prior year, the forecast language is measured, but its practical meaning is simple for people who fish. There will be stretches of the season when certain bays, river mouths, or nearshore runs are avoided because the water can turn opaque green and toxins can become a concern for people and animals. These conditions do not always kill fish in a way that produces a dramatic shoreline. They can change bite behavior, push bait out of a harbor, or create days when the water looks like it has been thickened. Charter captains keep their own records alongside public advisories. Some write down the first day they see scum on a lee shore. Some note the taste of the air when the wind shifts off a bloom. The details are minor, but they accumulate, and they change what a normal week looks like in midsummer. On the Pacific coast, the most widely documented recent shock came in late June 2021. When an extreme heat wave coincided with the lowest low tides of the year, intertidal shellfish cannot move away from air exposure when they are stranded by the tide. During that event, community members and researchers documented widespread mortality of clams, oysters, mussels, and other shellfish. The University of Washington described the die-off as the result of conditions aligning in a narrow window. Very low tides occurring during the hottest part of the day, across multiple sites. For growers and harvesters, this was experienced as an inventory collapse that did not resemble a disease outbreak. Beds that had produced reliably could be found littered with gaping shells. Losses were mapped by people who were used to measuring their seasons in quiet increments. Seed set, growth, harvest, and the slow work of maintaining gear. The observations were numerous because the coast is watched closely by those whose work depends on small changes in water and weather. In the years since, the term heat dome has entered common language, but the working memory of the event is more tactile. The smell of exposed shellfish, the sound of gulls over flats, and the fact that the losses were seen across a wide coastline rather than in one bay. In Alaska's Bering Sea, the anomaly that entered the public record most clearly was the collapse of snow crab abundance, which led to the cancellation of the harvest in 2022 and again in 2023. In late 2023, reporting tied to a peer-reviewed study described the decline in connection with a warm water anomaly that increased crab metabolic demand, with starvation as the mechanism proposed by the research team. The point that mattered to crews was not the pathway, but the scale. A fishery that had been dependable enough to anchor incomes and processing schedules simply did not open. In Dutch Harbour and other working ports, these kinds of changes ripple through the ordinary parts of life: gear loans, insurance payments, and the way families plan for winter. When crab are absent, boats pivot to other targets when possible, or they tie up. The anomaly is recorded in official announcements, but it is also recorded in the small signs that are not formal data. Fewer totes stacked on a dock, fewer pallets moved, fewer late-night pickups at a processor gate. The sea still looks like the sea, and that is part of the difficulty for people trying to explain the shift to someone who does not work on it. Across these different waters, the common thread in fishermen's reports is not a single strange object or a single dramatic episode. It is the rising count of days when instruments, catches, and water appearance do not line up with the prior routine. Hypoxia measurements in the Gulf quantify one kind of mismatch between surface and bottom. Algal forecasts on Lake Erie quantify another. Tide and heat alignment on the Pacific coast shows how narrow timing can become decisive. A crab collapse in the Bering Sea shows how fast a population can drop beneath a viable threshold. Each case has its own record and its own vocabulary, but the on-water reports tend to reduce to the same steady phrasing. The water is acting different, and it is happening more often. The lines on the screen that went quiet. The first place many crews notice a change is not in the net or the cooler. It shows up on the sounder. A working fish finder draws the water column as a constant stream of returns. Bottom hardness, bait layers, scattered marks, and plankton bands build a familiar picture for people who look at it every day. When that picture thins out, it is noticed in the same way a person notices a missing streetlight on a route they drive every morning. It is that expected structure fades, breaks, or shifts into thinner layers that do not match the season. In the northern Gulf of Mexico, one documented driver of this kind of mismatch is low oxygen near the bottom during summer. NOAA and partner scientists measure the hypoxic zone each year and report its size and conditions. On the 1st of August 2024, they reported a measured hypoxic area of about 6,705 square miles, larger than average, expanding bottom water that fish and bottom species may avoid. A hypoxic layer is not visible from the deck in calm weather. It can sit under a surface that looks ordinary. On a sounder, the change is indirect. Crews may still see bait higher up, while bottom-hugging species are sparse or displaced into edges where oxygen is higher. A trawl or longline set in the wrong band can come up light, even when the surface looks alive. A second source of confusion comes from stratification. In summer, warm fresh water from rivers can sit over denser salt water, forming a sharp boundary. The boundary can trap low oxygen below it and can also reflect sound differently than mixed water. Sonar works by sending pulses and reading the echoes. When the water column develops strong layers, returns can become messy, and the edge between layers can resemble a false bottom or mask weaker targets. Crews who change frequency, gain, or range can sometimes recover a clearer picture, but the underlying issue remains that the water itself has become more layered than their old settings assumed. It is the same electronics, pointed into a different medium. The quiet, described by many fishermen, is also tied to how fish distribute when conditions compress them into narrow habitat. A hypoxic zone reduces the usable bottom. A marine heat wave can shift temperature bands and move species earlier or later than usual. The result is not always a dramatic movement to a new region. It can be a narrowing. Fish gather into seams that may be smaller than the search pattern a captain has relied on. When a boat runs a traditional line of waypoints and sees fewer marks on the screen, the temptation is to treat the screen as the problem. Over time, many crews treat it as a sign that the water is no longer granting wide margins. The same dynamic appears in inland waters during harmful algal bloom seasons. NOAA and partners forecast and assess Lake Erie blooms because cyanobacteria can affect water quality, tourism, and recreation. NOAA issued a Western Lake Erie outlook in June 2024 that called for a moderate to larger than moderate bloom season, and later assessments described 2024 as moderately severe compared with 2023. In these periods, anglers often describe the water as thicker in some bays and river mouths, with visibility dropping. On a sounder, a dense bloom and associated suspended material can increase background noise and clutter in the water column display. The screen still works, but the meaning of what it shows becomes harder to read. A weak return that might have been a small school of bait on a clear day can disappear into the general haze of particles. There are also cases where the screen becomes confusing because the sea becomes louder. Underwater sound is not only produced by fish finders, it comes from ships, construction, and industrial activity, and it travels efficiently through water. NOAA Fisheries describes ocean noise as a growing area of study because many marine animals rely on sound, and human-made noise can affect the underwater environment. For fishermen, this does not translate into a single visible culprit on the plotter. It shows up as a background condition. More traffic in a shipping lane, more vessels working the same grounds, and more competing sonars in close quarters. In crowded fisheries, interference from nearby sounders is a known and ordinary nuisance. On some days, it is mild. On other days, it produces streaks and false targets that make a careful captain distrust the display. Scientific surveys capture a parallel version of the same problem. NOAA and its partners collect water column sonar data to answer questions about ocean ecosystems, and the agency maintains archives of these data because they are valuable for measuring organisms and habitat structure. Survey echo sounders are calibrated and operated under standardized protocols, but they still face the same physics. Layers in the water column, bubbles from wind or vessel motion, and changing sound speed with temperature and salinity can all alter what returns look like. The difference is that surveys treat these issues as measurement challenges, while working fishermen experience them as practical uncertainty. A trawl survey can log the data and later correct or interpret it. A small boat trying to decide where to set gear has to make the call in real time. In the Pacific Northwest, the role of timing and exposure became unusually clear during the late June 2021 heat event, when extreme heat coincided with very low tides. Researchers and coastal communities documented widespread shellfish mortality across intertidal areas because shellfish were exposed to air during the hottest part of the day. That event is not about sonar, but it illustrates why the water column picture can change quickly when conditions align. A fish finder is built for steady use in typical ranges of temperature and turbidity. When conditions push outside those ranges, the display remains technically functional while becoming less reliable as a guide to normal behavior. For fishermen, the mystery in the title is not a supernatural silence. It is the quieting of a familiar signal that used to track the season closely. The quiet screen also has a mundane, mechanical side that crews learn to check first. Transducers get nicked on trailer bunks or fouled with growth. Wiring can corrode in salt environments. Mounting angles matter when a boat is heavily loaded or running in chop. These are routine problems, and most captains separate them from broader patterns by comparing notes. If one boat's screen goes strange while others report normal marks on the same grounds, it is treated as an equipment issue. If multiple boats report that known edges look empty, the electronics stop being the first suspect. What makes the change harder to describe is the way these factors stack. A layered water column can reduce clarity. Low oxygen can push fish off the bottom. A bloom can add noise and reduce visibility. Traffic can add interference. None of these on its own has to erase a season's pattern. When several occur more often, the result is a slow increase in days where the screen does not match the calendar. That is the practical meaning behind quiet. It is a reduction in usable information during the part of the workday when decisions have to be made quickly. NOAA's role in monitoring provides fixed points that crews can use as reference. Dead zone measurements in the Gulf give context for why bottom habitat may shrink in late summer. Harmful algal bloom forecasts and assessments in Lake Erie provide a public record for the kind of suspended material that can change water clarity and sonar appearance. Water column sonar archives reflect how central acoustics are to measuring life in the sea and how much interpretation sits behind a line on a screen. These are not explanations of a single mystery. They are the documented background for why a fisherman's most trusted display can feel less dependable more often without any single dramatic cause. The water that looked normal from the dock. At daybreak, the surface often offers no warning. In the northern Gulf of Mexico, a skiff leaving Venice, Louisiana can cross water that looks plain and usable, with the river's brown plume fading into blue-green offshore. The difference that matters sits lower. On the 1st of August 2024, NOAA-supported scientists reported the measured Gulf hypoxic zone at about 6,705 square miles, a low oxygen layer near the bottom that can make seafloor habitat unavailable without changing the view from the rail. For crews who work close to the bottom, the first sign is usually not a dead fish or a surface slick. It is an empty stretch where the boat has historically been able to set gear with little hesitation. A captain runs toward known numbers, watches the sounder draw the bottom cleanly, and notices that the marks that usually sit tight to the seabed are thin or absent. The trawl doors still spread. The line still sets. The gear comes back with less than expected, or with species that look moved, into an edge that is only a short distance away. NOAA describes hypoxia as bottom water with very low oxygen that can force fish and bottom-dwelling species to leave. And that is how the change is felt on deck. Not as a single disaster, but as a shrinking of usable space. The Chesapeake Bay has its own version of water that appears ordinary, while conditions below become limiting. Maryland's Department of Natural Resources maintains hypoxia reports through the summer, and its 2024 year-end summary described oxygen conditions that were near to below average through much of the season, with monitoring used to track where low oxygen formed and how it shifted. The bay can look calm from a pier in Annapolis or a marina on the Patuxent, while the deeper channel holds water that no longer supports the same distribution of crabs and fish. A person standing on the dock sees wind and tide. A water sample and a dissolved oxygen profile show whether the lower layer can be occupied. In western Lake Erie, the mismatch between appearance and risk becomes more visible at times, but it still relies on measurement. NOAA's the 27th of June 2024 forecast called for a moderate to larger than moderate harmful algal bloom in the western basin, with the seasonal assessment later reporting a severity index of 6.6, described as moderately severe and more intense than 2023. On many days, the lake surface can look like ordinary summer water from a launch ramp. Wind pushes surface scums into coves, then pulls them apart again. The bloom's footprint and intensity are captured through satellite imagery and sampling, not by a single reliable visual cue. That is part of why fishermen and charter captains keep their own small records that read like plain maintenance notes. They write down when the water turns opaque near the Maumee Bay shoreline, when a faint paint-like sheen appears, when the smell changes after a wind shift, or when clients start coughing after spray comes over the bow. These are not laboratory findings. They are field observations that line up, sometimes uncomfortably, with agency bulletins that talk in severity ranges and indices. The normal from the dock problem becomes most obvious when a system acts on thresholds that people cannot sense. A hypoxic layer does not need to be dramatic to change where fish can hold. A bloom does not need to look extreme at a marina to be severe in the broader basin. The same day can contain a normal-looking surface and a bottom layer that changes how nets, hooks, and traps perform. These are not rare curiosities in the records. They are routine environmental constraints that are documented year after year, and they are part of why fishermen describe the anomalies as worsening. The number of trips where appearance and outcome do not match has grown in the working memory of crews who run the same routes. The days the catch log stopped matching the season. On working boats, the catch log is usually treated like maintenance. A page gets a date, a set of coordinates or a general area name, a start time, a depth range, a sea state, and the part that matters later, what came up and in what mix. When fishermen talk about anomalies, many of them are describing a pattern that shows up only after a few weeks of entries. The water can look normal leaving the dock, and the electronics can look normal for long stretches of a run. The record changes first. The entries stop lining up with what the same pages used to look like in the same month. In the Gulf of Mexico, late summer logs have long carried a kind of background adjustment tied to the seasonal low oxygen zone. NOAA-supported scientists measure that hypoxic area each year, and on the 1st of August 2024 they reported it at about 6,705 square miles. They describe hypoxia as bottom water with very low oxygen that can make habitat unavailable to fish and bottom species. A captain's log does not use that language. It shows it by omission. Bottom sets that once produced at predictable hours begin to produce later, or only at the edges of a familiar line. A page that used to include a steady mix becomes either sparse or oddly concentrated, as if the catch has been pushed into fewer workable pockets. The change becomes more visible when it reaches the dockside paperwork that fleets depend on to get paid. NOAA's Southeast Fisheries Science Center publishes preliminary Gulf of Mexico annual catch limit landings for species managed with ACLs, built from dealer reports and other reporting streams. Those tables are not written for drama. They are lists of species and numbers updated through the year. For fishermen and buyers, they function as an external yardstick. Whether landings are tracking close to recent years, whether a season is closing early, whether a fishery is unexpectedly slow, a captain with a log that suddenly looks off can compare it to those public updates and see whether the mismatch is only on one boat or whether it is showing up in the broader reporting. Shrimpers in the Gulf also work inside a reporting structure that makes the season legible after the fact. NOAA maintains a Gulf shrimp landings reporting process that collects trip and vessel level information for the year. It is designed to capture pounds landed by species and condition, and it includes X vessel value, the practical number that tells a crew what a haul meant in fuel and pay. Even when the sea behaves within historical bounds, a year can still read strangely on paper if the distribution of shrimp changes in space and time, forcing longer runs and tighter targeting. A captain's log can show that compression before an annual report does, with repeated returns to fewer coordinates and more notes about moving after short sets. Farther north, the catch log stopped matching the season has been described in public records through changes in management status and the kinds of notices fishermen see each year. Atlantic striped bass is one example where the mismatch is documented in assessment language, then felt on the water as changed expectations. NOAA's striped bass species page summarizes that, according to the 2024 stock assessment, Atlantic striped bass are overfished and not subject to overfishing. The update report produced through the Atlantic States Marine Fisheries Commission describes spawning stock biomass estimates and thresholds in 2023, putting the stock below the updated threshold. A captain's log does not write SSB threshold. It shows the practical side. Fewer keeper-class fish during weeks that used to produce them, shifts in size, structure, and more days where effort moves to other targets. Those changes are not uniform along the coast, and fishermen notice that too. A log from the Hudson River estuary does not look like a log from the lower Chesapeake, and neither looks like surfcasting notes from New Jersey. The common feature is the growing number of entries that read like adjustments rather than routines. People add more lines about time spent searching, not because they suddenly forgot their own grounds, but because the timing that used to hold is less dependable. Even without a single visible anomaly, the log begins to show more blank effort. Trips with long runs and fewer decisive sets, then a sudden clustering when fish appear in narrow bands. On Lake Erie, a similar paper trail exists. But the mismatch often shows up as avoidance rather than absence. NOAA issues seasonal harmful algal bloom forecasts and then a seasonal assessment that assigns a severity index based on bloom biomass over the peak 30 days derived from satellite imagery. For 2024, NOAA reported a severity index of 6.6, moderately severe and more intense than 2023. For charter captains and nearshore anglers, the logbook consequence is not always a visible green scum on every day. It is an increasing number of entries that include detours around river mouths, changes in port choice, and notes about water clarity or smell that coincide with advisory updates. A day can begin with normal-looking water at the dock and still end as an avoid day on paper, because the bloom is concentrated downwind or has shifted into a band where the boat planned to work. In Alaska, the strongest example of a season failing to match the log is when a fishery does not open at all. NOAA's Alaska snow crab species page states that the fishery was closed for fishing years 2022 and 2023, with the fishing year running from July 1 to June 30 under a management system that limits harvest by size, sex, and season. For working boats and processing towns, the log becomes a different kind of record. Tie updates, maintenance logs, loan payments, and gear checks that replace harvest entries. When Alaska later reopened the Bering Sea snow crab fishery at low levels, NOAA described it as open for the first time in 2 years, still in low abundance, with communities using regulatory flexibilities to operate. That shift is documented in notices and agency features, and it changes what entries exist at all, replacing expected runs with minimal, tightly controlled effort. What makes this feel mysterious to fishermen is not that data do not exist, it is that the data arrive at different scales than daily work. A hypoxic zone measurement can describe a large bottom water area, but a crew experiences it as a few coordinates that stopped producing. A bloom severity index describes basin-wide biomass, but a boat experiences it as a few ports that became inconvenient and a few downwind shorelines that became unpleasant. A stock assessment describes a population status, but the log is the place where that status becomes real, in the form of smaller fish, shorter windows, or unexpected gaps. When fishermen say it is getting worse, it often means the number of mismatched days is growing. Logs show more corrections, more backtracking, and more notes that used to be rare. The page becomes denser, not with fish, but with small operational decisions. The season still happens, but it no longer reads like a repeating template. The closures that came without storms. In most ports, closures were once associated with visible disruptions. A hurricane warning, a damaged channel marker, a fuel shortage, or a mechanical failure at a processing plant could interrupt a season. Crews expected those kinds of interruptions and planned around them. In recent years, a different category has become more common. Closures issued during calm weather, under clear skies, and in the absence of physical damage. These are recorded through agency bulletins, regulatory updates, and emergency notices that arrive while boats are still able to leave the dock. One of the clearest examples appears in the Gulf of Mexico shrimp fishery. NOAA and the Gulf of Mexico Fishery Management Council manage shrimp seasons through time area closures designed to protect juvenile shrimp and reduce bycatch. These closures are based on scientific sampling and monitoring, not on weather. In 2024, NOAA published multiple Federal Register notices detailing seasonal and temporary shrimp closures in offshore waters. Some were triggered by surveys showing small shrimp sizes in certain zones. For crews, the effect was immediate. Grounds that were physically accessible became legally unavailable, sometimes with only days of notice. The water did not change. The permitted map did. These closures are communicated through formal channels, bulletins sent to permit holders, updates on agency websites, and notices posted at docks. A captain arriving at a marina office might see a laminated map with new shaded areas, showing where trawling is suspended. The boundaries can follow depth contours or latitude-longitude lines that do not correspond to any visible feature. A boat can cross from open water into a closed zone without seeing anything change except a number on a chart plotter. In the Atlantic, similar patterns appear in striped base management. The Atlantic States Marine Fisheries Commission and NOAA Fisheries issue seasonal restrictions and emergency measures based on stock assessments and catch data. In 2023 and 2024, slot limits, seasonal closures, and possession limits were adjusted as part of rebuilding plans. Some coastal states implemented temporary closures during peak spawning periods. These actions were tied to biological thresholds and harvest projections. For fishermen, they arrived as regulatory updates during periods of otherwise routine fishing. The bays remained navigable. The fish were still present in some areas. The closure applied because of population models, not environmental disruption. On Lake Erie, closures and advisories tied to harmful algal blooms have followed a similar pattern. During the 2014 Toledo water crisis, municipal water intakes were shut down after tests detected microcystin above advisory levels. The lake surface at the intake did not show an obvious hazard. The decision came from laboratory analysis and public health thresholds. In later years, including 2023 and 2024, NOAA and state agencies issued recreational and water use advisories during bloom periods based on satellite data and sampling. Some charter operations altered schedules or suspended trips temporarily in response. These interruptions were triggered by toxin measurements rather than storms or spills. In Alaska, the closure of the Bering Sea snow crab fishery in 2022 and 2023 represents a more extensive version of the same process. NOAA Fisheries closed the fishery after surveys showed a sharp decline in crab abundance. The closures were implemented through formal regulatory action, not emergency weather orders. Ports, such as Dutch Harbour, remained operational. Processing plants maintained infrastructure. The fleet faced a season without legal harvest because the stock assessment indicated insufficient biomass. The decision was grounded in survey trawl data and population modelling, not in an observable collapse on the surface. When the fishery partially reopened at low levels in later seasons, it did so under tight quotas and restrictions. Federal and state announcements detailed the allowable harvest, opening dates, and reporting requirements. For crews, this meant a short window of activity followed by mandatory stand-down periods. Again, the limiting factor was not sea state or access, but compliance with biological reference points. Another category of closure comes from contamination and food safety monitoring. In Washington State and British Columbia, shellfish harvesting areas are routinely closed due to elevated levels of biotoxins such as domoic acid or paralytic shellfish poison. State health departments and NOAA partners test samples and issue closures when thresholds are exceeded. In 2015, a major domoic acid event linked to a marine heatwave led to widespread shellfish and crab fishery closures along the U.S. West Coast. Similar, smaller-scale closures have occurred in subsequent years. These events often begin with laboratory results rather than visual changes. Beaches can appear clean, tides behave normally. The decision to close is triggered by numeric limits published in regulatory guidance. Harvesters receive notices listing specific beaches, bays, or coordinates that are temporarily restricted. Access depends on toxin concentrations, not on visible conditions. In the Pacific Northwest, tribal, state, and federal agencies coordinate these closures through shared databases and alert systems. Commercial and subsistence harvesters monitor updates daily. A closure can affect only a few kilometers of shoreline, while adjacent areas remain open. The difference is defined by sampling stations and historical risk zones, not by what can be seen from shore. Closures related to endangered species interactions form another layer. In several U.S. fisheries, dynamic management areas are established when protected species are detected. For example, right whale protection zones on the Atlantic coast can trigger temporary gear restrictions or area closures when whales are sighted. These zones are announced through NOAA bulletins and maritime safety messages. A lobster fisherman may receive notice that a section of water is restricted due to recent whale activity, even though no whales are visible at the time of fishing. These closures are based on aerial surveys, acoustic detections, and reported sightings. They are time-limited and geographically specific. Their purpose is preventative rather than reactive. From the deck, the ocean can appear unchanged. The restriction exists because of data gathered elsewhere. Emergency fishery closures can also follow catch reporting. Many federally managed fisheries operate under annual catch limits. When landings approach those limits, NOAA issues closure notices to prevent overfishing. In the Gulf and South Atlantic, these notices are published in the Federal Register and distributed through fishery bulletins. A season can close in midweek after cumulative reports show that quotas have been reached. In these cases, the closure reflects paperwork moving faster than boats. Dealer reports, electronic logbooks, and observer data feed into centralized systems. When thresholds are crossed, the closure is activated. Fishermen sometimes learn about it while still at sea through radio calls or text alerts. Weather remains stable. The interruption is administrative. Across regions, these different closure types share a common feature. They are based on measurements, models, and regulatory frameworks that operate independently of surface appearance. Hypoxia surveys, toxin assays, stock assessments, protected species sightings, and quota tracking all feed into decisions that reshape access. Ports have adapted to this environment by maintaining bulletin boards, email lists, and messaging groups dedicated to regulatory updates. Some marinas display printed NOAA notices alongside tide tables. Processors monitor agency feeds to anticipate supply interruptions. Gear suppliers track closures to adjust inventory. For fishermen, the experience is cumulative. A season becomes segmented not by storms or breakdowns, but by regulatory boundaries that shift with scientific inputs. The closures arrive quietly, often in technical language, and alter routines that once depended more on weather than on data streams. The absence of visible disruption is what makes these closures stand out in memory. Boats remain seaworthy, channels stay open, the water behaves normally, access changes because of numbers reported in spreadsheets and laboratories far from the dock. The files that grew faster than the fish. By the early 2020s, fishing trips were producing more paperwork than nets were producing fish on some days. A single outing could generate electronic log entries, satellite position records, dealer reports, observer forms, landing receipts, and environmental data. None of these systems were created at the same time. They were added gradually, often after regulatory changes, stock declines, or court rulings. By 2024, they had formed a layered record that followed every permitted vessel from departure to offload. In the Gulf of Mexico shrimp fleet, captains submit trip reports listing fishing zones, effort hours, pounds landed, and gear used. These are transmitted through approved software to NOAA databases. The forms are structured to match management needs. They do not contain space for describing confusing sonar returns, thin bottom water, or repeated short tows. A day spent searching appears identical to a day spent harvesting efficiently if the final landings are similar. Satellite-based vessel monitoring systems expanded this record. Originally introduced for enforcement, these systems now preserve long-term movement histories. Analysts can see how routes change, how fleets cluster, and how effort shifts away from traditional grounds. Over multiple seasons, these tracks show gradual compression into smaller working areas. In the database, it appears as altered spatial density. Scientific survey records form another archive. NOAA research vessels conduct standardized trawl, acoustic, and plankton surveys. Each cruise generates thousands of data points on temperature, oxygen, species composition, and size distribution. When conditions are unusual, survey technicians document them in cruise reports and metadata files. These notes remain stored even when no immediate management action follows. Observer programs and electronic monitoring systems add operational detail. Observers record discards, bycatch, gear conflicts, and safety-related changes in effort. Camera systems capture similar information where observers are absent. These records reveal how often sets are abandoned, reset, or relocated. Over time, they show increasing fragmentation of fishing activity, with fewer long continuous tows and more short attempts. On Lake Erie and other bloom-affected waters, monitoring systems operate in parallel. Satellites estimate cyanobacteria biomass. Buoys measure temperature and oxygen. Laboratories analyze water samples for toxins. Each dataset has its own reporting schedule and uncertainty range. Together, they produce seasonal assessments. Individually, they offer partial views. A captain may experience reduced water clarity weeks before satellite indices peak. The official record reflects the change later. Stock assessments attempt to integrate these streams. Assessment teams combine landings data, survey indices, age structures, and environmental variables into population models. The resulting reports determine quotas and rebuilding plans. They summarize trends over years. They rarely reflect short-term instability that dominates daily work. Timing is a central reason for continued gaps. Dealer reports may arrive weeks after landing. Survey results are processed months later. Environmental datasets are updated on different cycles. Regulatory responses follow formal review periods. Fishermen adjust immediately. Their notebooks record changes before they appear in public documents. To compensate, ports have developed informal data networks. Dock managers, processors, and association staff monitor agency feeds. They circulate summaries through email lists and messaging groups. Captains compare these updates with their own observations. Agreement reinforces confidence. Discrepancy creates uncertainty. Many crews now maintain private record systems alongside mandatory reporting. They track search time, water color, temperature changes, fuel use, and gear performance. These details rarely enter official databases. They function as personal archives, allowing comparison across years. The accumulation of records has not eliminated uncertainty. It has redistributed it. Agencies rely on large data sets that smooth variability. Fishermen rely on small data sets that capture it. Both describe the same waters from different scales. By the mid-2020s, a fishing season unfolded across multiple platforms. Tide tables, oxygen maps, bloom forecasts, quota dashboards, and closure notices became part of trip planning. Decisions were shaped as much by database updates as by weather. The anomalies reported by fishermen exist across these systems. They appear as thin survey indices, shifting vessel tracks, shortened seasons, delayed openings, and irregular landings curves. No single file explains them. What remains is a growing archive that expands every year. It records effort, movement, and outcome in increasing detail. It shows how often crews have had to revise routines. It preserves evidence of change without resolving it. If this video caught your interest, please like and subscribe for more. Leave a comment with what you'd like us to cover next. Thanks for watching, and see you in the next one.